boost in deeper waters. And brown algae is what most of the seaweed you see in the ocean is kelp, which gives its chlorophyll a boost in deeper waters. And which gives its chlorophyll a boost in deeper waters. Which gives its chlorophyll a boost in deeper waters.
Chlorophyll in chloroplasts. Done school biology remembers that chlorophyll in chloroplasts only makes oxygen in sunlight, and it's done school biology remembers that chlorophyll in chloroplasts only makes done school biology remembers that chlorophyll in chloroplasts
sort of satellite data of chlorophyll signatures in the water and predict when cholera might outbreak in Bangladesh, showing that you can correlate sort of satellite data of chlorophyll signatures in the water and predict, showing that you can correlate sort of satellite data of chlorophyll signatures in the water and predict, showing that you can correlate sort of satellite data of chlorophyll.
And someone said,
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 Chlorophyll.
Fred said, what keeps the leaves there?
Although technically chlorophyll is what makes trees green, Fred Smith was asking a bigger question. He was thinking about food chains.
You obviously had producers. They are the energy suppliers to whatever lives off of them. Then you have consumers on top of that, and we know them as herbivores.
The popular idea at the time was that the number of producers limits the number of herbivores. In turn, the number of herbivores limits the number of predators that feed on them. Every level was regulated by the amount of food from the bottom of the food chain going up. But this view didn't explain why herbivore populations don't simply grow to the point where they eat all of the leaves on the tree. Professor Smith had discussed this conundrum with two colleagues, Nelson Hairston and Lawrence Slobodkin. They proposed a new idea. The number of herbivores must be controlled not only from the bottom up, but also from the top down.
The herbivores had the capacity of destroying the plant community. Trees could be defoliated. But why weren't they defoliated? And the answer was because there weren't enough insects around to do that, and that was the role of predators.
The world is green because predators keep herbivores in check. This was a radical concept that became known as the Green World Hypothesis. Up until that time, no one thought predators had any role in regulating ecosystems.
This class was the first public vetting of the Green World Hypothesis.
And one of Smith's students, Robert Payne, would be the one to put this idea to the test. A few years later, as a new professor at the University of Washington, Payne went looking